Swayam Prabha. Digital India. Educated India.
In the first session, we have tried to understand whether our browser is trusted, and if it is not, how we can make it. In the coming session, we will see whether our system is trusted. The computer that you are using, or laptop or desktop, can you trust it? Yes? You tell me your term.
So, I mean, there are a lot of techniques for intrusion. So, I won't say that I will keep a lot of my sensitive data on my PC.
Okay.
Because I would never prefer to do that. I'd rather keep it on my hard disk than leaving it on my PC. So, I don't think I would trust my PC 100%. It would be just 30% out of
But only backup is sufficient?
No, not just the backup. Obviously, we need to harden our systems as well.
How?
By some settings, installing some video privacy software. So, obviously, we can't really ensure 100% privacy because there's something or the other new coming up, exploiting the.
Simple. For me, give me a system with no net connection, with no facility, there is no net connection. So, browser is there, but there is internet connection, Wi-Fi or wired not available. Don't give me pen drive, don't give me any CD, don't give me any hard disk, external hard disk. I just want one OS earlier previously installed. Cannot be called as safe.
If you just use it
Like?
Yeah, I think you can, if you only use it for, using the Paint or the Microsoft Word and that's it.
Okay. Great. So, whether you want to solve our purpose, can you stay in this area now where I don't have net facility? Something like people say ki there is a Anna Vastra Nivara, and now next one is internet. So, check whether our system is trusted and how we can make my system trusted. This is my session. Feel free to ask question in between also. During this session, I am going to talk about need of trusted platform module TPM, some terms, some RTM, RTR, we will see those things. Applications of TPM. TPM stands for Trusted Platform Module. The TPM, the research on TPM that is currently going on. This is the application list. Again, the way I have shown you in the first session. It's another list. TPM, it's a Trusted Platform Module. CRTM, that is Core Root of Trust Management. DRTM, it's a Dynamic Root of Trust. SRTM, Static. There is the endorsement key, then there is the attestation key, storage root key. Then there are some algorithms that has written there, SHA1 and HMAC. You must have seen yesterday. Hash algorithms. So, RSA, the grub. If you have a machine which is like Windows as well as Linux, a dual bootable system, it shows one UI first. You can select either Windows or Linux or memory test and all those things. There is a grub come into picture, that is the system. BIOS, when you start your machine, the first thing that comes into picture is BIOS. IPR, that is the initial program loader. MBR, SML and DIR. Here DIR is data integrity register, not a directory. I know you are not working right now in industry and doing working from home, but surely in couple of years time you will be getting this facility, work from home. Okay? So, let us see, you are on the laptop, you want to connect to your office system. Okay, not doing surfing, but some code. A time has come, people are there. I was also doing the same thing, sitting at my place, using the build system which is available in my office from my home laptop. Now that transaction, in the first session we have seen ki people are greedy to see what I am doing, what data is getting exchanged between my machine and the build system in my organization. How I can stop it? I cannot send everything as HTTPS. So there is a tunnel. You must have heard like VPN or tunnel earlier. So that is a tunnel. There is a VPN connection. Sufficient? Is it sufficient? Let's check it out. This is one thing where we require trusted computing, because you need to trust the build system in your organization, as well as your organization system should know that this system that I am getting connecting to the system externally, which is not in my intranet site, whether the system is trusted. The second one is your cell phone, your mobile, your laptop. You are going to from one location to other location and it is stolen. You are connecting to public Wi-Fi, free available. Actually, my mom used to say ki don't talk to strangers. Somebody is giving chocolate or cookies, don't take it. You go to Majestic, there is a Wi-Fi available, use it. How I can use it, I don't know, but I use it. So those things, those systems, knowingly or unknowingly, are helping me or helping the attacker to take my data out, which I don't want, but I am sending it knowingly or unknowingly. How I can stop these things? People are there who are also, I have shown you the diagram, there is an internal firewall, there is the external firewall, but people are there who are trying to clear those things, penetrate those things. What is the solution? Provision of critical services by trusted platform module on the local host. Capability of host to measure integrity of host software. Protocol to communicate the integrity measurement from host to the remote party, that is my machine at my place to the system in my office. Means of remote party to access the integrity measurement and determine level of trust in the host. All these things are possible with the help of a tool or a component, hardware, and that is called as a trusted computing tool or a module. What is trusted computing? The components and mechanisms that are compatible with the specification of TCG. TCG stands for Trusted Computing Group. The trusted platform, it is a computing platform that has a trusted component, probably in the form of built-in hardware. I am trying to put word hardware, software or data on my machine, on my hard disk. I am not going to trust at all. It should be some device, some hardware device which I feel cannot be compromised easily. I am going to show you that TPM chip also got attacked, it is compromised, but not easily compromised. Trusted component whose failure can break security policy. The next line, you can see the trusted component and trustworthy component. There are two different lines. Component that won't fail, 100% security, possible है क्या? Okay, so let's talk about how we can use this system. The first thing is, if I want to check my system whether it is, I can trust the system or not. Can the system is booted securely or trustedly? How I can do it? What do? You power on the laptop or desktop. There is a power on button. You click on it. Something happens. Some software happens at the back, runs at the back, and then you get the command prompt or the beautiful GUI, and you say, okay, my system is up now. And then you start doing some open gedit, open VI editor, or use some command prompt, or open Firefox browser and do some surfing. But during from your power on till the machine, the first UI that you get, UI or GUI that you get, what happens in between? What happens first for you? Probably OS loads. But from OS, from where OS comes? To run this code, everything should be in RAM, right? OS on a hard disk, possible like a, can you do it? No, OS should be in RAM, so that OS will run, then that will run your, that will load other programs of yours. So first OS should come. From where OS comes? OS is in BIOS?
No, the BIOS is the first program that runs, which initiates the OS kernel.
Perfect. So from where BIOS comes? Where is the BIOS?
BIOS is stored in the
Hardware. Again, are you saying? Are you getting one thing? There is a trust the hardware. There is a BIOS. What happens then?
So it loads the OS kernel, and then our OS is started by the bootloader.
Perfect. But now during this process from BIOS, when BIOS is trying to load the OS kernel, whether this OS kernel is not compromised, how you can trust? BIOS coming from hardware, I trust, but OS coming from hard disk or your secondary devices. So can I trust that? Can I trust that OS which is stored on your machine, on your hard disk, secondary devices? It can be tampered, your hard disk can be tampered, so your OS can be tampered. If OS is tampered, your BIOS is trustworthy, it will not fail, but your OS which is coming up now is having a bug, is having a leak. Can I trust that?
So we can trust it if we can at least prevent, the detection of pen drives on boot, so that it can't.
It happens afterwards. Once your OS is loaded, whether your all the required softwares are loaded, then only your pen drive will be detected and all those things, right?
So we can also detect pen drives on booting by booting another OS slide, which can be used to tamper our OS kernel.
So it means what?
That we can prevent by changing the bootloader's order and not setting the priority to the lowest for a pen drive or an external device to be detected on the boot itself, like right when the boot.
Perfect. So first check whether your OS is trusted. How you can do it? You are coming from let's say Pune. Whether you have a device with you that can first test your OS if it is not buggy. If it is not buggy, then only load. So everyone need to carry another device, pen drive kind of device, to check whether your OS is not buggy. And if it is not buggy, then load. And if that is also hardware that you are carrying in your pocket, it may be also get stolen. So the hardware that you are carrying externally, can I trust that? No. So what I want is my BIOS before loading operating system, can it check whether the previously used OS is not tampered? Previously, let's say 8:30 to 10:30 you have used your laptop, 10:30 to 10:45 when you are taking your breakfast or tea, your machine was shut down. 10:45 you entered the room again and you started the OS. Between this 10:30 to 10:45 your OS is not tampered. Can I check? And if I can check, it means till 10:30 it was working correctly the way I want. Then at 10:45 also the same thing like 10:30. It means I can trust. How I can do it? I can do this thing. We can do this thing if we can compare the previous version or previous used OS with the currently available OS. But let's say the OS is 1 GB. When I start my system, if I will start comparing every 1 bit of previous storage and current storage, 1 bit by 1 bit, then I need to compare 1 GB data and check whether the data is not tampered. If it is same, data is not tampered means OS is correct, I can use it. 1 GB data. can I change it the other way? Can I have hash value of the previous OS and hash value of the current available OS? Hash value, it can be 160 bit. Okay? So that 160 bit hash value I can easily compare in probably no time. So the previous hash value and the current hash value, if they are same, I will say ki the OS is not tampered, start it. Exactly that is called as secure boot. The previous hash of the OS and current hash of the current OS, they are compared, and if they are found untampered, we will start the OS. That is called as a secure boot. But there is one more facility called as a trusted boot. Something like the previous hash is not same as the current hash, the hash of the current system. Then the system gives alert to the user. The system gives alert to the user. Okay, there is a change. We have seen the change in the hash. Do you still want to proceed? Do you still want to proceed? Then it depends upon the user to load the OS or not to load OS. If user says load OS, then into system will start the OS, even if it is compromised or tampered. But now it is the convenience of the user is taken into consideration. That is called as a trusted boot. Secure boot, it will not allow the OS if it is tampered, if the hash value of the current OS is not same as the previously stored hash value, it will stop. That is what we are talking about, the trusted boot and the secure boot.
So in trusted boot, the user itself sets the OS as a trusted OS, or is that, I mean, how is the trust property?
The first level, it comes from the manufacturer and then the user is loading it first time, then that hash is stored. User is allowing or not allowing the changes to happen in the system. Something like, let us say there is a OS is there, Linux is there, and there is security patch is coming. Now security patch, if I install security patch, if I put that security patch on my system, the hash value with that will be always different than the previous version. So now it is my job as a user, yes, this is the change I have made in my OS. So now henceforth this modified or updated OS is the OS for my base system.
So every time a new OS is dual booted or booted on the system,
Dual OS nahi, OS
any OS
and update is
for the first time, a trust boot happens and thereafter secure boot,
actually trusted boot or secure boot happens every time you start a machine.
both of them.
Nahi, secure boot is both of them will happen if the way you configure it. If you can configure it for trusted boot, if the change is there, it will alert me. Secure boot, if there is a change is there, it will stop me starting the system. Okay? It depends on user. I will select trusted boot, then it will always alert. If I say allow, it will go to the next one, next level. Okay? But again I am saying when a security patch is added, it is the user is adding it, so it is user choice is there now. Okay, now the previous base will be gone and now the updated version is the base version for me. That is done by user first, every time it does. So this is a secure boot and the trusted boot. Now it depends upon user to go for opt for which one. This is secure boot. You can see the last line, the computer is stopped if secure boot guarantee is violated. Okay, it will not start your OS. From where I can get this thing? I need to store hashes, right? The hash value of OS, then different other applications. I have started operating system. Okay, my OS has come up. I want to start VI editor, but my VI editor is not tampered. How will come to know? Or my Firefox browser that I want to open is not tampered. How I come to know? I require hash value of that, and then when application loader is going to load Firefox, it first check whether the previous hash is same as the current hash of Firefox. If it is same, then allow Firefox to start or give some message ki okay, there is a probable tampering is happening with Firefox application tool. So again I require hashes. Where I will show the hashes, I require not software, because some hardware device, and that is a TPM chip, a trusted platform module chip, TPM. There are different companies which provide these TPM chips: Atmel, Broadcom, Dell, HP, IBM, Infineon. The diagram that I have shown you on my first page, there is a chip is there, that is a Infineon chip. The what is availability? Hardware chip, currently 100 million laptops they are having these chips. Around $2 to $3 I can get one TPM chip. $2 to $3 means around what, 300 to 400 rupees, 70 rupees right now, around 300 rupees.
So it will compare hashes, no? If I can tamper hash.
The hashes are stored where?
No, sir, online there are.
They are. No, but the hashes are actually stored right now in the TPMs. If I want to compromise, modify the hash, I require to tamper the TPM.
That can't be done.
No, it is in hardware. I will show you. When TPMs can be compromised, I will show you that also. Okay. So where that it is not the only chip. The TPM chip is actually residing on your motherboard. This is the motherboard layout where the TPM chip is placed. You can see here the TPM connected with the LPC bus. Okay, can you see it? Here there is a TPM which is connected to your system BIOS with the LPC bus. There is a reason that TPM is connected to this LPC. Devices found on LPC bus are BIOS, the legacy input output devices. TPM sits on LPC bus. TPM is, by putting the TPM connected to LPC, it allows me to measure BIOS. That is, my BIOS is not tampered. So first I check for BIOS non-tamper. If it is not tampered, then the next thing will come. The LPC bus is easier to write software for, and it is 33 megahertz bus. This TPM is having such kind of components. There is the input devices, there is a cryptographic coprocessor, there is the HMAC engine, the SSH engine for hashing and comparison, the non-volatile memory, there is a non-volatile memory in the form of EIK and SRK. There is a random number generator available. There is a volatile memory in the form of PCR. These are all registers, and there is the execution engine. The input output component, it performs protocol encoding and decoding. The power detection, TPM requires notification of power state changes. The opt-in provides mechanism and protection to allow TPM to be turned on off. By default it is not on, I require to set it, I have to start that TPM. These are the things that we need to focus more. There is a cryptographic coprocessor, there is a RSA engine used for digital signature and encryption. There is a symmetric key algorithm engine also available, which encrypts the authentication information, provides transport communication. There is a HMAC engine, provides proof of knowledge of the authenticated data. There is a SSH engine. As I said, there is a 160-bit hash is generated for the applications or the system that you use, and those hashes are getting stored. So that is 160-bit hash is generated using SSH1 engine. It is part of your TPM. There is a random number generator for your RSA and all those things. You require to have some random number, so that random number generation, there are two things, one is called a random number and another pseudo random number. So, this system, that is a random number generator TPM, generates the random number using this component, using nonce key. There is an execution engine which executes commands received from input output. There are commands like do hash of this value, measure the hash value, run the next level or load the next command, all those things come here. There is a non-volatile memory used for EK and SRK storages, and as I said, volatile memory used for PCRs. These PCRs, the next slide will show you, there are different PCRs, one for each different module. These registers, the TPM registers called as the platform configuration registers. The current system, the current TPM is running with the version called as 1.2. The IC that I have shown you, it is the TPM 1.2 IC. It supports 24 registers to store integrity measurement. Each register is 160-bit storage location, shielded location in TPM. It is a part of TPM hardware. How we can measure or how we can put more data in that. The first one is when you start the system, all the registers are initialized to 0, and then it is called as the PCR extensions. So, there is a PCR I value, I is current index of PCR, 0 to 23 are the different indices, 24 registers available 0 to 23. So, PCR of I, that is PCR of particular index, equal to SHA1 of current PCR plus the new measurement. So, that is called as we are trying to extend the PCR I, PCR 4 or PCR 13, PCR 17 and so on. This is called the PCR extension. PCR extents are not commutative. Obviously, measuring A and then B is different than measuring B followed by A. Simple. If you have a machine right now, you can start your Linux machine and just write one file containing your name, okay, and just perform MD5 some space file name. It generates some hash. Okay. You can do it now or you can try it later also. So, there is a file, let us say xyz.txt, which contains your name. You are trying to find its hash. So, the command can be MD5 some file name or checks SHA1 some file name. When you do that, it will generate the hash value. File can be of any size, but it will generate fixed byte or fixed bit number of hash value. Okay. Here SHA1 will generate the 160-bit hash value. So, this hash value is stored with some, let us say, in variable x. You modify the file your xyz.txt by 1 bit or 1 character here and there, making instead of small a you can convert it to capital A, or let us say instead of saying ABC you write ABCD, or instead of ABC you write AB now, and find its hash again using MD5 or the SHA1, the same one. You will find the change, drastic change in the hash generated. So, hashes are different. A change in 1 bit will change the hash drastically. I am talking about 1 bit, here I am taking 1 character, 1 character is 1 byte. Okay. So, now these values are changed. What I am saying now, I have a package A, software A, its hash value is stored in PCR 5, suppose. Now, after package A or application A, I am going to load application B. To load application B, I require to find its hash, and that hash is also getting extended in PCR 5. So, total hash which is stored in PCR 5 is hash of A and then hash of B. Instead of this, if I first load B and then A, what will happen? There is a hash of B first and then hash of A is getting added there. That is the line I have done here. The PCR extends is not commutative, that is measuring A then B is different than measuring B and then A for A. Okay? PCR can track unlimited number of measurements, but because hashes are getting extended to the same PCR, so it can go along. This is the list of PCRs 0 to 23. ठीक है. You can see here first 1 to 13 those are actually used for the system purposes. The PCR 0 is used for CRTM, BIOS and platform extensions, 1 for platform configuration, 2 is for option ROM code. Go down on line number 8 you will find bootloader stage 2 part 1. I will show you on a sequence diagram here. You can see what is bootloader part 1, part 2 and then actually OS is getting loaded. So 8, 9, then the bootloader command line arguments, 15 not in use, 16 not in use, 17 is used for DRTM4, 18 to 23 not in use. These not in use can be used for our applications, for our codes, for our purposes. Now what is root of trust measurement? Goal is to measure system state into PCR. So there is a tool that I want to load. Let us say we have its hash is generated and loaded into the particular hash, particular PCR value. Using PCR, a communication party can be convinced that the system is in known state. Let us take this machine, I am the server and your laptops are my clients. I want to, without coming to all of you, I want to check whether your system, because we are in organization, we want to check whether, I want to check whether your systems are following the policy, security policy which is generated for my organization. So what I will do? I will send one request, a command from my machine to all your machines. Then your machine will generate some number based upon your system configuration, your hardware configuration, your software configuration, how they are upgraded or not, everything will be generated as a number and that number will be given back to me. And then I will say whether this number and the number I am looking for, if it is same, then the machine is following the security norms of my organization. If not, then some action need to be taken on your machine or on the corresponding employee. Okay? That is that communication party, that is statement saying communication party can be convinced that a system is in the known state, that I should know that your system is in the state that I want always. Okay? System users are not prevented from running any software they want, but the execution is logged and cannot be denied. Perfect. From the RTM, the trust is extended to other system components. This concept is called as transitive trust. What I am talking about? There is a sequence of the steps that need to perform. Let us take, I am going to start my OS Linux, let us say Ubuntu 14.04. Once the system is started, then the next job I should do is to check whether my malware, anti-malware is updated or not. So my OS need to check that my anti-malware running on my machine is trusted or not, whether it is hash is changed or not. If it is not changed, then start it, then upgrade it and then modify the corresponding way the hash value. All those things should happen. After my anti-malware is running, then check whether my Firefox, let us say I use Firefox, whether my Firefox is updated or not, whether it is not tampered. If it is not tampered, then only load Firefox. It is a chain, OS, then anti-malware software, then Firefox, then another tool, another tool, another tool. So those are in chain, and those chains B will check for C, because C will be loaded after B. B will be loaded after A. So A will check for hash value, what is called the measurement. The measurement of B will be done by A. Measurement of C will be done by B. If C is correctly measured, then B will load B will load C. Later on, suppose I want to load D, which is on top of C or after C. So C will look for hash value of D and perform the measurement check. If it is available, that is the chain, that is the root of trust chain, transitive state. What are the steps involved? Measure, that is compute the hash value of the next entity. BIOS measures OS loader and so on. The measurement is extended in one of the TPM PCRs. Control is passed to the measure entity, that is A is checking measurement of B. If B is loaded, now the control will be available with B. B is going to load C, so measurement is found correct, then control will go to C. That is what the statement is talking about. This process is continued for all components of the system up to the user level applications. PC client specifications defines which PCRs are used for what. We have seen there are different PCRs. So, the PCRs which are not in use right now, those can be used for our application softwares. Measurement change with system updates and patches perfectly. If I modify Firefox or update Firefox or update kernel, I require to change the hash value, because otherwise my system will never come up, because it will say that the hash is changed. After kernel modification, after system configuration modification, the hash need to be recalculated and stored. This chain of trust that I was talking about is given in this slide, E0 to E1 to E2. Okay? There is a line, to trust En, one must trust En minus 1. Okay? So, simple. If you come here to attend this session, the first thing, you are trusting me directly? No. You are trusting ACM, because ACM is trusting to PS, and now PS has called me. So, PS trusting me. So, in turn you are not trusting me. Are you getting me? Now, what is static root of trust? Here fixed है. Static root of trust means I will execute the softwares in this way only. That is first Firefox, then VI, then Eclipse, and so on. So, it is a sequence is fixed. It is fixed from day 1 to day n. The applications will be loaded in the system in this way only. That is static root of trust. There is another way. What is static root of trust? I will execute in this fashion only. But whether it happens all the time, I am in hurry, I want to book a ticket. So, whether first I will check whether my system is updated or not, whether my Firefox is updated or not. What I will do? Open browser, trust or not immaterial, can I go to yatra.com or some redbus.com and book it. So, there is a change in the sequence of application softwares loading into memory. For that, there is a dynamic root of trust is required, and for dynamic root of trust, the PCR that is used is PCR number 17. PCR 17 is used for this DRTM. By default, if you start your TPM, actually the PCR values are initialized to 0, but this is the PCR which is initialized to -1. The default value of PCR 17 is -1. There are commands after S enter or SK init, it is set to 0. Extend PCR 17 with hash of SLBs. TPM can detect difference between malicious resettings and the DRTM request. So, there is a facility. Somebody will say, okay, DRTM is used for application software development, application software testing, change can happen, who can trust? But the facility is available with TPM, whether the hashing that is stored in this PCR is right or it is buggy. The facility with TPM is there. Not only that, whatever actions are getting performed by user or the software getting loaded in the system, those are getting logged. The logging is required. Even if you start your machine right now in Linux, there is a file called as a /var/log/messages. So, those files are storing your activity there. Who has logged in, at what time, login is failed continuously 3 times, means there is a chance of somebody is trying to breach a system. So, all the things getting logged in the system. There is a logging facility, event logging is available using SML in our TPM. Now, let us go on to that using TPM for trusted boot. How it happens? The first thing I said is there is a grub. If you remember, I said something like bootloader part 1, bootloader part 2. You can see it here. There is a stage 1 activated after the BIOS has initialized the core part of the system hardware. and this stage 1 loads stage 1.5. What it means? To load stage 1.5, first the measurement of 1.5 need to be taken, that is hash of 1.5, that part is stage 1.5 is taken, compared. If found correct, then stage 1 will be loaded. Now stage 1 is in the active part. Now what it does? Located in the first 30 kilobytes of hard disk. From where it is come? In MBR. So first 30 kilobytes are for the stage 1.5. It takes. It compares the stage 2. If stage 2 is found correct, untampered, then it loads stage 2. It loads the default configuration file and other modules which are required, that is kernel modules which are required. So there is a TPM, what is the init, there is a command called as the init. So TPM init will first check for BIOS, found correct, go to MBR, correct, bootloader, boot sector, boot block, boot manager, and then it loads the OS loader, and then it starts the operating system. Look at the title of the slide. Because I fixed it, I don't require dynamic change here. System will get booted, I will get a command prompt or I will get a UI if I follow these steps only. A fixed it, it is static. Okay? Now how it actually happens? Whatever steps I have shown you, those are in the form of now sequence diagram I am showing you here. There is a CRTM, it first measures the BIOS, that is check for BIOS setting, hash value, stored hash value, if they are same, then what? Then if CRTM BIOS is correct, then PCR extend will happen. The PCR underscore extend is the command. The first one is init, then the PCR extend. Which PCR I am trying to extend now? 0. CRTM, BIOS, those are getting hash are getting stored in PCR 0. Getting stored in PCR 0 means I am trying to extend PCR 0. Then once PCR extension is done for PCR 0, then the execution happens. It means now it loads the BIOS in the system. Once BIOS is stored, BIOS is going to measure system devices, and the system devices, if they are found correct, those will be extended in registers 1, 2, 3, 5, 6 and 7. Okay? If it is done correctly, then I will look for the bootloader. The bootloader is found correct, then loaded into PCR 4. It goes on to the operating system. The measurement is stored in your 8 to 14 registers, and then your operating system is loaded, is in the place right now in RAM. I get a command prompt, or I get a UI, or I get a GUI, and then I will open another application. Those are called as the application, and for loading those applications I require a application loader. And now that application loader will come to picture, checking the hash values and all those things, storing it in PCR 17. That will start from this location onwards. How it happens? There is a software called as a trusted grub. So this trusted grub, it is an extension to the standard grub bootloader, modified to detect and support the TPM functionalities. This software, now the different version is also available. Trusted grub, the trusted grub that I have used is trusted grub 1.5. Once you install it, you will find the changes in your file called as a grub.conf. Okay? There is a file called as grub.conf which stores this information. This data is after the trusted grub is installed. You can check the file with this, you can see the hash here stored for etc password. There is a hash stored, etc shadow hash is stored. So if changes are made in etc shadow or password or group, signal is sent to the system. There is a change in shadow file, change in password file. ठीक है, and we can stop it, or we can, based upon my user requirement, I can allow or I can deny. Now what are the components for this thing? You can start from the bottom here, root host, CPU, then CRTM, BIOS, bootloader, stage 1 and all things, and you can see there is a additional files, those are your configuration files. If you remember, I said that my system is now getting trusted, whether my browser is trusted. I have made a changes, right? In the first session we have seen how we can configure the browser is configured. Now these browser configurations are stored in some files. For Firefox it is a prefs.js file and users.js file. There are two files where these configuration files are stored. How I can come to know that my file is not tampered? My Firefox configuration file is not tampered. How will come to know? If I will store a hash of pref.js and I will compare that hash with the current hash, then I will come to know whether the file configuration file is tampered or not. If it is not tampered, it means my configuration is right. I am not saying my Firefox executable is right. Firefox executable is different, Firefox configuration file is different. Are you getting what I am saying? There is a Firefox executable, that is firefox.exe or firefox.out or something like that, and there is a pref.js. Once firefox.exe will load, it will use pref.js or user.js. This will allow me pref.js. Also I need to look for the Firefox executable, whether it is trusted or not. So that is what I am saying, that the additional files also can be checked for this untampered thing. That is the trusted grub component part. How I can report these things? I have said now logging, XML and all those things. This is the RTR is there, it is a root of trust for reporting. There is a mechanism to securely report that state of platform to a third party. What will happen if some changes are happening on my machine? The log is generated, but the log is also tampered. Your machine, as I said, let's say it is connected to me, to my main admin board. Data is changed there, something is changed there, the log is coming to my machine, but the log itself is tampered. So what I believe? I believe yes, your machine is following the company norms, but actually machine is not following the norms. So what I require? The data coming from your machine to my machine or reporting happen is also happen securely.
In that case, we can check the router's log to identify.
So for that, the first thing is a nonce is generated. I require that my system will generate one random number, some nonce that will send to you. Something happened on your machine, some hash is generated on your machine. That hash along with nonce will come to me, and that nonce and that thing I will check whether it is not the repeated attack, that is something is same data is coming to me, because the random number is generated each time differently, some different number will come, I should get the same number back different time again. So I will come to know that this is the log is generated at the current time coming to me without modification. So all those things will come into picture or are handled by this RTR system, and that is called as the remote attestation protocol. On the left hand side you can see the client system, on the right hand side is the system which is going to verify you. Okay? So what it does? The challenger or the system verifier, I am the system verifier. What I will do? I will generate one nonce which is 16-bit, 160-bit. That nonce will come to your system. A request is made to generate the hash value of your PCR. Along with your PCR and that n will come to your attestation service, and attestation service now send me your PCR with the same nonce, and all these things are signed. Digitally signed data will come from your machine to my machine. The digital signature will tell me that the data is coming from your system only. Okay? So all these things are handled using that RTR, but where to store? this storage, this RTR and all those things need to be storing some data, right? So there are two things possible. There are two approaches, without PCR and with PCR. Without PCR, the activity is called as a bind and unbind. There are commands PCR underscore bind, PCR underscore unbind, PCR seal, PCR unseal. Using these commands, we can handle those activities. There is a binding happens. This binding happens outside the TPM. It should come after TPM because TPM contains these PCRs. So these values should be taken out and then those should be bound and sent back. Encrypt data with the public part of TPM key. There are keys, I have shown you EIK, AIK, SRK. Those keys, the encryption happens. Only the TPM that the key pair belongs can decrypt the data and private key can be generated inside the TPM. Binding to these keys are the public and private key of one TPM will be different for the other TPM device. So they are not same. Okay? The unbinding, that is a decryption of this data using the TPM's private key. What I am talking about is sealing and unbinding or sealing, binding and unbinding, those are given here. Sealing, a way to combine measurement, the PCR content and external data. Encrypt externally provided data with reference to specific PCR state. It is PCR 17. I can say, I can ask for PCR 17 data. Give me PCR 17 data. If I can get PCR 17 data, also I will get a SML. So I will come to know which applications are loaded in the system and in which order. So SML contains which order, which softwares, and based upon that, what is the hash generated, I will come from the PCR 17. So PCR 17 and SML will come back to me, that is to the verifier. I will come to know which softwares right now, which application softwares are running at this point of time on your machine and in which sequence they have been started. Okay? So that information will be available to me. Only the TPM that seal the data can do the unsealing. PCR values specified do not have to be platform current PCR values, but can be some other specific PCR value also. There is the unsealing activity, that is the decryption part that I have said to you. We have done many things in TPM. What is the limitation? People say it is a hardware, it cannot be tampered. It is a tamper resistant but not tamper proof. TPM only provides a guarantee at software load time. If a legitimate application is loaded and then modified in memory, we have started the Firefox. I have shown you about.config. Firefox is loaded by OS. Okay? You are using some commands or using some click. I have started the Firefox now. It is untampered. Machine is Firefox is started now. It is loaded in the memory for use by the user. I am going to about.config now. I am going to change the settings now in Firefox browser settings. This is a tampering of Firefox configuration after it is loaded in the memory. So this system is not testing that changes are happening in the software after loading. Before loading, yes, it is doing it, but after it is loaded, we cannot do, because we are trusting the before loading activity, the current software before loading, the current configuration before loading. Once it is loaded, means the control has gone to Firefox. So there is no way the previous application can check the Firefox integrity. Okay? That is what the limitation is there. The TPM does not protect against an attacker who exploits a flaw in currently executing software. So Firefox is loaded and it is using some OpenSSL, and that OpenSSL is having some bug, and the attacker is able to exploit that bug. Already loaded in the system, in the RAM, it is executing, bug is there, I am the attacker, I am going to attack that system now, gone. Even if having limitations, but there are some TPM applications, the PC login, can see 88% of PC logins can be done using or are done using this TPM. User authentication, secure boot sequencing, smart cards, fingerprint biometrics. These are some applications on the authentication side. On the network side, you can access controls, the wireless systems, device authentication. As I said, I want to see whether your system you are connecting to my network, whether it is following my norms, that I can test it. Device attestation will come into that part. The secure mailing, full encryption, all these things are the applications of TPM. These are the systems right now in place. Leading Japanese pharmaceutical manufacturer is having 27 seats, having Lenovo PC with TPM. There is a Fortune 500 firm, they do full encryption of your data. If you are running with Microsoft Windows right now, with the latest devices and there is TPM available, there is a software available which can help you to encrypt your device, encrypt your hard disk right now also. Okay? So, the WannaCry attack kind of stuff can be mitigated. There is a law firm which performs the full disk encryption to prevent data breaches. There is a pizza maker Pepperino with over 370 restaurants, uses Dell laptops and desktop with built-in TPMs to automatically encrypt all communication between stores and headquarters and to secure passwords and bank account numbers. This is right now available. It is not in, I am not saying it is in air, it is there in place right now. Attacks? Yes, there are attacks possible on TPM. This person Tarnowski, he has used the electron microscope, identified the core chip, and if you check, if you remember, this TPM chip is connected to LPC bus. So, he using this activity, he has breached that bypass. He has created a breach that bypass the chip integrated tamper prevention measures. So, now whatever changes are happening in TPM, because of those probes, he is able to see what is the PCI value stored. Found critical information that can be stored, that can be used to create counterfeit chips. But for that, I require to open the device. Okay? I need to have the physical access to this device. There is another attack, TPM reset attack. The person Bernard Kaur, what he has done is, there is a LPC bus, he has insulated a wire to it, connect L reset command, reset to LPC bus. So, whatever changes happening, those will be ignored or nullified. There is a lot of research is happening in this area in TPM. Right now, you have seen there are 24 registers, out of 24 some 7 registers are available to me, and then I can use dynamic root of trust. So, on each PCR I can put the data, the applications hashes on that. So, this is what is the approach one. What is happening is same number of DIRs as PCRs. Expected value of PCR are stored in DIRs. Every time its PCR is filled, its hash is computed and compared with the corresponding DIR. If the value match, then continue boot process, otherwise halt the process. The idea here is, do I require so many hashes, so many PCRs? Can I use the same PCR, one PCR or particular PCR and then use it instead of requiring those many PCRs? Today I require, let us say, 24 registers, tomorrow some other applications are coming, so I want another PCRs, so can I reduce it? And that is actually approach 2, use only one DIR. Right now what is happening is, for each PCR there is one DIR. So, there are 7 PCRs, so 7 PCRs available to me, I will have 7 DIRs for me. Can I reduce it to 1 DIR? That is my approach 2. Find cumulative digest of all expected PCRs. Store the cumulative digest in DIR. Each time PCR is filled, cumulative digest is generated and getting compared with the DIR value. So, lot of work is happening in this part. Need of prioritization of TPM error conditions. if your static zero trust or dynamic zero trust is giving me failure notations. So there can be multiple exceptions or multiple errors are reported. What happens is, not always the first error that comes to me is the high priority message. These priorities can be converted into, let's say, low priority, medium priority or high priority. High priority job need to be looked by the admin immediately in less than 1 hour time or 1 hour, 30 minutes time. So if exceptions are coming to me, which exceptions need to be handled first? So can I track them? Can I segregate them and allow first the high priority processes, high priority exceptions need to be handled, then medium, and then so on. Because what is happening is there is a log is generated and the log is containing a mixture of signaling, high, low, medium, again something like that. So can I segregate these logs? Can I parse these logs? And based upon the high priority, those logs can be shown to the admin first. So prioritization of these error messages is another job. Not only that, parsing basically. I will report, okay, this is bug level 1, this is bug level 2, bug level 3, but the bugs are coming. I require what? The coming bug I require to classify whether it lies in the level 1 to 3, and based upon that pass it on to me. But also there should be facility that suppose there are multiple logs of, let's say, class 1, which is a critical job. So I require to maintain the queue. Based upon the queue I require to, as an admin, I will take the bug and then try to handle it. So I require to maintain that kind of queue also. So all that activity and research is going on in this area. The next one, there is a random number generator. This functionality which is internal to TPM to check the operation of RNG, as if RNG fails then it will be in a serious issue. RNG stands for random number generator. If you remember, for that verification, a random number is generated, a nonce is generated and goes to the system, the client system. If that RNG system, that is a random number generator system, is compromised, what will happen? It will generate the same number. If you are knowing C programming, then there is a function like random or random number generator. So you can specify, I want to generate random number between 1 to 50. So what will happen? It will generate some numbers, but first 50 numbers it will generate, let's say, randomly, but 51 it may be from the same previous numbers. So that is a false random number. So that false random number can generate me the same nonce which is used previously, and the same nonce coming to me, it means I will say, okay, the same data is coming to me, data is untampered, which is not correct. So generation of pure random number generator is also a task which is coming up. Virtual TPM. Virtual TPM is what? A software TPM kind of stuff. Let's say I have a laptop right now, but it is not having TPM chip. What I will do? I want to do all those things. I want trusted boot and all those things. How will you do it? I don't have TPM, throw the laptop, buy new laptop. Simple, no? Because the TPM chip comes, let's say, $2 to $4, but it is fitted on the motherboard. The motherboard, if my motherboard is not having that kind of slot, the motherboard is of no use. So I need to throw the motherboard, right? It means I need to buy some another thing. So instead of that, can I go to software TPM or virtual TPM? Yes, there are software TPMs available. Okay, you can go to Sourceforce site, sourceforce.net. You can download different software TPMs. Software TPM 3665, 3776. These are available currently in the form of software TPMs. You can download those things and use it. But they are not going to provide the activity the way hardware TPM provides, obviously, because it is again a software, it's an application going to run after your OS is loaded. So the trusted boot or secure boot will not be available, but generation of hashes, generation of signature or attestation is possible using these software based TPMs or virtual TPMs. those are available on, if you go to sourceforge.net site, you can get the software TPMs. Let's come to the summary right now. The TPM is a hardware chip on almost all motherboards nowadays which are coming up. Recently I had just checked that $1 USD, it is $1 USD. It is now crossed, it is 2 to 4 US dollars it comes. It's a hardware based. The current version of TPM is 1.2. The root of trust, it is a measurement, RTM and RTR, RTS these are required. Benefits, it enhances the confidence in the platform, low cost, exportable quality. Limitation, even if they say it is a, we cannot modify, there is a tamper resistance is there, but no tamper proof. Passive width, because they can help me to load a system only. Once the system is loaded, if something is happening on the software which is loaded, I cannot do anything on that. Okay, that's what I'm saying, it's a passive. What is the applications? The e-commerce, the government applications, online banking, file encryption, the PIN regenerated, they can be done using these TPMs. These are some of the references. The book Practical Guide to Trusted Computing is available on net. You can download and read this thing. Thank you.